Hello, pre-calc students. This is Coach H here with a little walkthrough video for you to help you as you complete your quilt square project that we're going to ask you to do this week in pre-calculus. The first thing I want to begin with is to make sure the first time you jump onto Desmos that you make sure that you sign up using your school email address. It will be important that you create an account. That will give you the ability to save your work and then also access it if you don't complete it all at one time. And that's going to be important. We'll use this a few times throughout the year, so creating this account now will just help you out down the road. So that's step number one. Make sure you log in and save your work. All right, I'm going to jump over to a different tab and I'm going to show you what I created as an example for this quilt square project. Now, I want to go through some requirements here real quick that are also on the info sheet that should be in the Google Classroom. So first off, you're going to need to create a square. And you're going to do that by just copying down the first four equations that you see in my example. Those two horizontal and two vertical lines will create that that basically 10 by 10 square from -5 to +5 on both the X and Y axis. And you're going to notice that there are some domain and range restrictions that are included on the end of those as well. We're going to talk more about those in a little bit. So step number one is to create that square. And again, if you access the info sheet that's in the Google Classroom, these are listed out for you. So all you have to do is copy those into the first four equations. All right, the next requirement is that you need to use all 8 parent functions that were in our library of parent functions. Now, you've already got the constant function covered by the fact that you completed that square that your quilt square is going to fit within. And so again, we've got the constant function already a part of that, and you can see that here in equations 3 and 4. Now, if you take a look at the equations that I have listed out here, I have listed out all of these equations in order of how I use them based on how they're listed in your library of parent functions. So if you want to see how I utilized one of those graphs, you can just find that again in order of the parent function. So you got your absolute value functions here in red, square root functions in green, quadratic in blue, cubic in green, our reciprocal function in purple, and then last but not least, our greatest integer function or step function at the end. So again, that's requirement number 2. You need to use all 8 parent functions at some point in your project. Requirement number 3 is that you need to use a total of 20 unique graphs, not including the 4 that were used to create the square. So when you get done, at a minimum, we should see that we've got 24 equations total. You'll see that my quilt square took 28 to get it the way that I wanted it to look. But again, 20 unique graphs, and those graphs can be repeated. And then last but not least, the final requirement is that all of your equations need to be restricted so that they fit within that square. As you can see here, none of my graphs extend outside of that quilt square that we created in step number 1. All right. So those are your requirements. Now I want to walk you through a few things that are going to be helpful to you as you kind of go about this process. So the first thing I want to talk about is just inserting an equation, okay? And so if I just go ahead and click on the next box, right, I can just start typing an equation in. So if I wanted to put a line at y equals, let's say a -3x plus 7, you can see that that line pops up on my graph now, okay? And then obviously this line is extending its domain and range or -infinity to +infinity. And so that's extending outside of my box, okay? So if I want to add restrictions to this and I want it to fit within that box, all right, there's a little hint that you can use in Desmos that's going to help you. You'll notice that since I have this graph selected, notice there are these gray dots that pop up, and it's kind of popping up at all the intersection points at other graphs. So if I wanted this red line to just extend but it so that it shows up only in the black diamond that's as a part of my graph, okay? So I'm going to go ahead and highlight that point, and you can see that my line intersects that black diamond at the point 1,4. So now I have a decision to make. Do I want to restrict this graph in terms of its domain? And if that's the case, I would look at the x values. If I want to restrict it based off of its range, I'm going to look at the y values, okay? And so I'm going to go ahead and restrict this. Well, let's start out with its domain, all right? And so I'm going to go ahead and put a brace, and then I'm going to always start with my lower bound, right? So since we're doing the domain, let's go 1 is less than x. All right, so you can notice I've now cut off the top of that graph because I don't want it to be less than the number 1. And now I'm going to come down here and look at this intersection point, which is the point 3, -2. And so now I want that graph to only show up where it is less than 3. And then I'll close my brace. And you can see that that line now only shows up in that area, okay? Now, let's do the same thing, but let's restrict it based off of its range just to show you it doesn't matter which way that we go. All right, so again, if I go back to that point, all right, I want this point to extend from -2 on the y-axis, that would be the lower value, to 4 on the y-axis. And so I can just go ahead, same idea, but restrict that from -2 to 4. And again, you can see now if I restrict it based off of my range, that line is showing up accordingly, okay? Now, I will point out, if you take a look at my reciprocal functions here in graphs 23 and 24, you're going to notice that I had to restrict it based off both the domain and the range. And that was because if I don't include the range ones, for example, notice that that graph now extends outside the top and bottom of my graph. So it was important that in this situation, I did actually have to include both of those values so that, again, on the reciprocal graph, it stayed within the frame, okay? So that's how you input an equation. I will point out that if you take a look, you also have this keyboard down here, and if I pop that up, that's going to give me some mathematical commands. So if I need to put in an exponent or a quadratic or my absolute value or the square root symbol, which you are going to need to use, just pop up that keyboard and that will help you there, okay? All right, the last thing that I want to show you, well, two more things actually, is next I'm going to show you how to change colors of the graph. So you'll notice that my equations are kind of grouped based off of color. So if I had this line added in and I wanted to change its color, I'm going to click on the little gear symbol up at the top, okay? Now, the one thing that we want to be careful of, don't hit the X. That will delete your graph. And obviously, I don't want to hit delete all. But in this gear setting, I can come down and click on the color, and that will give me some different options. So let's say that I wanted this line to be, let's go purple, and I wanted to make it a dashed line, and I also wanted to make it thicker, all right? I could come in and I could change those things within that, again, that gear symbol. This gives me all kinds of options to go ahead and change things within my graph. And then when I get done, I could click on the new equation, or you saw there was a done. Now, the last thing I want to show you with, and this is important to keep track of, is I want to make sure that I save on a regular basis, all right? So again, I'm logged in, so this gives me the ability to save my graph. So I'm going to click Save Copy. Oops, I logged out of my account. So if I was logged in, it would give me the ability to save. So now you can see I'm logged back in. So now you can see that I can save it. Notice the little check mark goes, hey, you're saved. And notice that as long as I don't make any changes, that save button doesn't even show up. So that tells you if this button is dark, that everything in my work up to this point is saved. But once I start to type in another equation, you'll notice that it now shows blue, and that's telling me, hey, you've got changes that haven't been updated and saved. All right? So that's a little walkthrough of kind of how to use Desmos and the requirements of your project. So we look forward to seeing your creativity. And if you have questions, just make sure you ask your teacher. All right, everybody have a great day.